Hey guys, it's Tony from Archism. Today we're going to be getting into solving some kinematics problems. This time we're going to be using the simple speed, distance, and time formula to solve these problems. So let's get right into it. So right here our problem is, and our two problems today are going to have an electron in a television tube travels the 27 centimeter distance from the grid to the screen at an average speed of 5 times 10 to the 7th meters per second. How long does the trip take? And our part B is going to be an electron in a current carrying wire travels at an average speed of 6 times 10 to the negative 5th meters per second. How long does it take to travel 27 centimeters? Okay, let's get started on part A. Already read the problem, so let's get right into it. So if you guys remember the speed, distance, time equation, I really like to remember it in this way, as speed is going to be equal to our distance divided by our time, because usually in our SI units that's going to be meters per second, and you can always remember that speed is going to be in meters per second. So if we have that, what we're trying to find is how long the trip is going to take. So if we have our equation right here, speed equals distance over time, then we're just gonna we can see that easily by doing some division and solving for t. We're gonna get our time is gonna be equal to our distance divided by our speed. So what's that gonna be in this particular problem? We have 27 centimeters, and since we like to keep our distances in our base SI units as in meters, seconds, and meters per second, what we're going to do right here is we're going to have 27, since it's in centimeters, we're going to multiply it by 10 to the negative second meters divided by our speed, which is 5 times 5.00 times 10 to the 7th meters per second. And if you divide that out on your calculator, what you're going to get is 5.4 times 10 to the negative 9. Seconds. So as you can see, it's going to be a really small amount of time that it's going to use to cross this very short distance. Remember, it's an electron, and this electron, this particular kinematics problem is kind of realistic because the electron is able to travel at this speed, and if you remember, electrons can travel very close to the speed of light. And it's over a very small distance, so it's going to take a very short amount of time. So let's move on to part B. So very similar to our last problem, all that's going to be different is that we're going to have a different speed right here. But it's still going to be asking us for how long it's going to take us to get over this distance. So if you guys remember from part A, what we had was our time is going to be equal to our distance over our speed. So if you have that, you just go back to your distance, 27 centimeters, or 27 times 10 to the negative second meters, don't forget your units, divided by your speed, which is going to be your 6 times, or 6.00 times 10 to the negative fifth meters per second. If you divide that out on your calculator, what you're going to get is 4,500 seconds. So the reason that this is going to be much larger than what we got in our last problem is that you're going to be traveling the same distance, but what you see is that you're going to have a much smaller average speed, 10 to the negative fifth versus 5 times 10 to the 7th. That's going to result in the electron, or whatever it is, you can replace this electron, you can replace it to be in a different situation. It's going to take a much longer time than something that's going much faster. You guys, if you have any questions that you'd like to send us, please send it to our email right here at archismgroup@gmail.com. And as always, please like, subscribe, and thank you for watching. I'll see you next time.